Hello, my name is Rob Reynolds. Welcome to Calculus 1. Today we're going to be looking at section 6.1 and we're going to be exploring the difference between displacement and distance. And I think you already know that if you have a velocity function and you take the derivative of it, you get the acceleration. Well, if you integrate velocity, we will get displacement, which is total area underneath the curve, positive and negative, where distance is the absolute value. I think I can explain a little bit better maybe through some graphs. So the displacement, even though this is positive and this is negative area, you can see that we're going to be subtracting because this is a negative area. So I'm actually taking the positive and adding a negative, which is the same thing as the first area minus the second area. That's displacement. Where if I talk about distance, it's always positive. So I'm going to take positive and then either subtract off a negative, which will make it positive again. So that's why they're going to take positive plus positive for distance. So looking at our first example, I've already graphed the velocity function here for you. You can do that likewise on your graphing calculators. So we're done graphing, but it says determine the movement, whether it's a positive or negative direction. So basically, from here to here, all the values, all the y values are going to be positive. So we need to find this point of intersection here, and you can do that by factoring or setting the velocity function equal to 0. You could always just guess left, guess right, guess on your calculator as well. If I divide everything through by 2, it makes things a little bit easier to factor. So I can see pretty quickly that I have intercepts of 3 and 1. So, and I can also see that between 1 and 3, all of those y values are negative down here in red. So I think for answer A, I would have something to the effect of between times 0 and 1, I have positive direction, and between 1 and 3, I would have negative direction. In part B, they ask for the displacement, and the displacement is going to make a distinction between this positive yellow area and this negative green area. So remember, for displacement, I need to take into account positive and negative. When I get to the next example, distance is always positive. But for displacement, I'm going to keep the positive and the negative. So for part B, in order to find displacement between 0 and 1 is where they want me to go first of all, I would integrate the function between 0 and 1. And the fundamental theorem of calculus, I would come up with 8/3. I would continue to integrate between 1 and 3. Of course, you could do this on your calculator. Here I've just asked my calculator to graph or integrate between 1 and 3, and you can see it's negative 8/3. And then finally they ask to integrate between 0 and 3. Well, that would be 8/3, the yellow, plus the green, and that would be 0. So displacement means he's right back to where he started. He traveled a ways, and then he returned to his initial position. So displacement is the total distance traveled cumulatively from start to end. But distance would be the positive distance that he traveled in both directions. So even if he did go out for a time and then came back, we would still continue to add that distance up. So for part C, I would have to integrate from 0 to 1, and then I would add a negative area because I knew that this was going to give me negative area here, so I'd have to go a -1 times the negative area in order to make it positive. So I know that this is negative between 1 and 3. So I'm integrating between 0 and 1, which I already know that that's 8/3. And then I would add a -1 times this -8/3, and that gives me a total of distance of 16/3. So here's how the author answered part A and B. Again, just a nice little picture, and you can pause the video and check out solutions. I'll run over another example with, after a couple more definitions, the position of the velocity, or excuse me, to find the position given velocity, all we need to do is integrate the velocity to find the position function, and then to find the velocity, if given acceleration, all I need to do is integrate the acceleration function and add it to the initial velocity. So the initial velocity plus the integral of the acceleration will be my velocity. And to find the position function, we're just going to integrate velocity. So an example of that would be shooting an artillery shell straight up into the air. So the velocity would be decreasing from the minute that it was shot off until it reached its highest point, the vertex, and then velocity would start to increase again. So if I use the formula, I'm given the acceleration, and I think I'm looking to find velocity. So I'm going to use the definition, and it says the velocity is equal to the initial velocity plus I'm going to integrate from 0 to t the acceleration, and the initial velocity is given as 300, and the initial acceleration is given as 9.8, but I know that that's gravity, and gravity is forcing it down or slowing the object down, so it's actually a negative 9.8. Even though in the problem they said 9.8, I know that that's forcing it down. So I would find the velocity function, and I should probably put this in terms of t, in terms of time, and the direction says find the velocity for the shell for time greater than 0. So this is it. And so what's happening is that would graph this function where the velocity initially starts out decreasing until it reaches its highest point, and I could find that highest point by setting this equal to 0. So about after 30.6 seconds, I would be at the vertex, and from that point, then the velocity would become negative, and then it would be descending back to Earth. I hope this video is helpful. If you have any questions, feel free to email me.